In the last video we looked at simple linear regression, residuals and predictions, and confidence interval for the slope. In this video we are going to focus on using the model to either estimate the mean response at a particular x value or to predict an individual response at a particular x value. So we'll use the lions example again, and we'll think about a collection of lions, all of whom have a proportion of black pigmentation in their nose that's equal to 0.6. So think of the entire population of lions, and so in particular here we're looking at male lions in Tanzania. So think about the entire collection of male lions in Tanzania, and think about the subset of that population of lions who have a proportion of black pigmentation in their nose that's equal to 0.6. And what we want to do is we want to estimate the mean age for that subset of lions. So how do we do that? Well, our best guess for the mean age is going to be given by the predicted value right on the line. But we know that we just have a sample of 32 lions from that population, and so there's going to be some sampling error in here, some sampling variation, and so we need to express the uncertainty that we have in our estimate, and we do that using a confidence interval. And the language that gets used here sometimes is we're going to calculate a confidence band at the value x equal 0.6. And so to do that, we're going to use the prediction function again. So we used this before in the last video when we were just looking at the predicted value, so the value on the line, but now we're putting a band around that, or a confidence interval around it. And so we set this argument here, interval equal to confidence. We can take a look here and see all the different arguments. So here it talks about the interval, so the type of interval calculation, and down here in the details it's going to tell us what to set that argument to for the different types of interval that we can calculate. So in this case what we don't want to put in there is confidence. And we're going to set this argument equal to true as well, and so that's going to give us a little bit more in our output as well. So let me run that code. So we get all this output, and this is the predicted value. So for this subset of lions that have 0.6 black pigmentation in their nose, the prediction right on the line is 7.267278 years. So we're estimating the average age for this subset of lions to be 7.27 years. And then the interval, the confidence interval, is these two numbers here, the lower bound and the upper bound. So we're 95% confident that the mean age for this subset of lions is goes from 6.22 up to 8.31. The reason I wanted to print out this piece of the output as well, so the 0.5127235, is because it gives us a little more insight into where this interval comes from. So if we take our prediction or our estimated value on the regression line and then plus minus the critical value times the standard error of the fit, then we can get our upper and lower bounds. So this just gives us a little more insight into where the interval is coming from. Let's add confidence bands to our plot. So what we can do is we can do that calculation for every value of x, or every predictor value in the sample, and so it's going to give us an interval around the line all the way along, and then we'll just join those intervals up and we'll get these confidence bands here. And so the way that this particular function does this is it makes this nice shaded confidence band. So this represents our confidence intervals for estimating the mean age for lions with a proportion of black in their noses going all the way across the sample range. And one thing that you should notice here is this is not a parallel band. It's a little bit narrower in the middle and wider at the ends. It's narrowest at the sample average value of the predictor. So that's down here, and then it gets wider as we get further away from that sample mean. Okay, so that's a confidence band, and that's when we're trying to estimate the mean response for a subset of the population with a particular predictor value. By contrast, let's suppose we're just interested in one lion that has a proportion of black pigmentation in its nose equal to 0.6. So just one lion here, not a whole subset of lions, but just one individual lion. And let's try and predict the age for that individual lion. So our prediction is going to be the same as it was when we were trying to estimate the mean for the subset of lions. It'll be the value that's right on the regression line, 7.27. But now our uncertainty is going to be a little bigger than it was when we were trying to estimate the mean. When we're trying to estimate the mean, we've got a subset of lions. Some of them are going to be probably a little older than we're predicting. Some of them are probably going to be a bit younger than we're predicting. But when we average that out, our uncertainty about where the mean age is for that subset of lions is expressed with this interval here. So we're 95% confident that the mean age for that subset of lions is in this range here. But now what we're doing instead is we're trying to predict the age for an individual lion, and that could be a lion that's much older than we think, than we're predicting, or it could be a lion that's much younger than we're predicting. There's no way to kind of average out that discrepancy because we've only got one lion. So we can't have all the older lions balance out the younger lions and be able to narrow down our mean to quite a narrow range. We're just talking one lion here, and it's possible it could be a really old lion, it's possible it could be a really young lion. So when we put a prediction interval around this prediction for an individual, then the uncertainty is a lot bigger than it was when we were trying to do a confidence band for a mean. And so we're going to be able to see this empirically by using this predict function again, but now we set our interval argument to prediction, and if we run that code, we get the same prediction on the line as before, so the 7.27, but our interval now is much wider. It goes from 3.70 up to 10.84. And if I put it on the graph, so this one is the confidence band, and then now if I run this graph, what did I do? Oh, I had to do this in 2 steps. There we go. We get a much wider band, and that's because, as I say, it's much harder to predict an individual y value than it is to estimate a mean for a whole subset. So what we've covered in this video is estimating a mean value of the response variable for a subset of individuals who have a specific value of the predictor variable. That was represented in this graph. And then we've also looked at predicting an individual y value for a single individual with a specific value of the predictor variable. We've got a few more things to talk about with simple linear regression. So in the next video, we'll look at doing a hypothesis test for the slope in a simple linear regression model.